In this video, I'm going to do a brief overview of alkyl halides. I won't be going through the entire handout because most of it is video guided with video lessons embedded within, but I'll be doing the overview and doing a few examples with you. Do make sure you go through the videos to complete the rest of the handout and gain the necessary understanding for the course. So alkyl halides are essentially like hydrocarbons, except now what you've done is you've added a halogen to the hydrocarbon. And the typical halogens used are going to be either fluorine, chlorine, bromine, or iodine. And when they become part of a hydrocarbon or part of an organic molecule, the way you name them is you name them as follows. Chlorine would be chloro, bromine would be bromo, fluoro would be fluorine would be fluoro, and iodine would be iodo. And so essentially the general formula you'd see for an alkyl halide. So here's an example. We'll do CH3, CH2, F like this. And so its formula is C2H5 and then F. And so what you'll notice is essentially this is just like the formula that you would see for, let's say, an alkane, but one of the H's was replaced by an F. So if you were to write a general formula for it, you'd have CN, H, 2N, minus 1, and then you'd put an X over here. So you have one less H than you normally would. And then the reason is because of the halogen represented by the X, where X can represent I, Cl, F, or Br. And you're going to go and learn more about this by watching this video here. You'll see some examples of alkyl halides and you'll provide some names. And then you'll also learn about why the CF bond is stronger than all the other halogen carbon bonds, the CX bonds there. So do watch the video to gain some more insight on that. When we are naming alkyl halides, the halogens will be the same priority as alkyl groups like methyl, ethyl, so on and so forth. So in other words, they'll have lower priority than double bonds and triple bonds. So we just treat them like a regular alkyl group that you've seen so far, and just proceed with alphabetical order when you're deciding an order if you don't have any higher priority items. But in this situation here, for example, if we're numbering our carbon, we're not going to start from this side. Just because we have a halogen, the double bond still takes the priority. So we'd start by counting here, 1, 2, 3, 4, 5. And then the chlorine would be at carbon number 4. You wouldn't go the other way around. So you wouldn't go 1, 2, 3, 4, 5, because then you didn't give priority to the double bond. And again, these are the same priority as regular alkyl halides. So in this tutorial video, you'll see the common halogens that are used when you're naming alkyl halides. And we've already seen them above: fluorine, chlorine, iodine, and bromine. And they were called chloro, bromo, fluoro, and iodo. As you continue watching tutorial videos, you'll get a list of rules for how to name alkyl halides. So do watch that and write the list of rules over here. Essentially, it's not too different from naming any other compounds. You're just treating the halogens as a substituent, and you're giving them the proper name and following the alphabetical order rules as we learned earlier. Then you'll go through these videos here, and you'll be given the name of a molecule, and you'll have to draw the molecule out. So you're going to do practice problems along with the video. And same idea with the remaining tables. You'll be given some practice problems in the videos, and then you'll have to try to solve them. Well, I'll do a few with you over here. So here we have the IUPAC name, and we want to try to draw it. And it doesn't matter which one you do. I'll do a bond line diagram for this one. We have 1,4-difluoro, 2-methyl cyclopentane. So I'm going to start by drawing the parent chain, the cyclopentane, as you can see here. The pentane part means that there's only single bonds in the parent chain, and that there's 5 carbons. That's what the penta means. And the cyclo means it's a ring. So don't forget that. That's a common mistake that students often make. So we'll make our pentagon over here. 5 carbons, 1, 2, 3, 4, 5. Doesn't hurt to double check. And then we have our numbering done. So we have 1,4-difluoro. So we'll make this carbon number 1, doesn't really matter which one. So this is carbon number 1. And then we'll go this way, 2, 3, 4. There's another fluorine. And then 2 methyl. And that's the CH3 there. So 1, 4 difluoro, 2 methyl cyclopentane. Notice that the fluorines were named first because F comes before M methyl in the alphabetical order. Why do we start carbon number 1 over here and not, let's say, here or here? That's because it gave us the lowest number of substituents overall at the first point of difference. Let's try the next one. So we have 3-ethyl 2-iodopentane. I will do a condensed diagram for that one. So pentane, again, meaning we have 5 carbons. Actually, I'll do an expanded diagram for that one. 5 carbons. And ane means we have only single bonds in the main chain. On carbon number 2, doesn't really matter which side we start from. We have an iodine, so I'll make this carbon number 1. This will be carbon number 2. And then on carbon number 3, we have an ethyl. And now we're going to fill in the rest with H's. So H, 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 like that. And now all our carbons are full with their bonds. Let's do the last one here, 2-chloro-3-methyl-butane. So that is butane. That means there's 4 carbons. So 1, 2, 3, 4. On carbon number 2, there is, so it doesn't really matter where we start from. Let's start here, a chlorine. And on carbon number 3, there is a methyl. And I'm going to make them condense of CH3, H here because there's already 3 bonds from the 2 from the carbon, 1 from the chlorine. H here because there's 3 bonds from all the carbons, and then H3 here. And there we have our condensed formula for 2-chloro-3-methyl-butane. So we've drawn all these examples out, and you can go retry them in the video. Here you'll have a variety of molecules and names shown, and you'll do the practice problems as the video plays. So do that to get more practice. And then here you'll have names given to you, and you have to draw them, and you can see the keys for each one provided to you over here as well. We'll do one example together, maybe 2 examples. We'll try an alkane, and then we'll try an alkene. So let's go ahead and try the 2-bromo-5-methyl-hexane. So hexane is 6 in the parent chain. So 1, 2, 3, 4, 5, 6. Carbon number 2 has a bromine on it right here. And then carbon number 5 has a methyl. So that's 2, 3, 4, 5 right there. How come we didn't name this one carbon number 2? Well, it's because bromine comes first in the alphabet. So we would make this one carbon number 2 instead. So 1, 2, 3, 4, 5, and then 6. Let's try the 5-iodopentene. So pentene means there's 5 carbons, and the pentene part, the ene part, means there's a double bond in there. So we're going to draw 5 carbons. Now, because there's no indication of where the double bond is, that's implied to carbon number 1. That's where we place it at the end over here. So this will be our carbon number 1. Then we start counting 2, 3, 4, 5. At carbon number 5, there is an iodine. Why didn't we call this carbon number 1? Well, that's because, remember, the double bond gets priority, not the halogen. Then you can go and fill in the rest of your molecules. So here we have H2. Here we have H2. Here we have H2, H2, and this would be H2 as well. And so this represents 5-iodopentene. You should try the other problems. and then check your answers in the keys provided to make sure you understand how to name alkyl halides, which really isn't that different from naming regular hydrocarbons. You just have to make sure you use a proper prefix for each of the halogens, and remember to treat them like regular alkyl halides in terms of priority, therefore using the alphabetical order.